Welcome to Study Loop.
So we have a volume of diatomic gas, which starts off at 1 atmosphere pressure and 420 Kelvin temperature and expands to 1 point, and goes to 1.6 atmospheres pressure and 720 Kelvin temperature. But this happens where pressure changes linearly with temperature. So let's say pressure goes as some P naught plus alpha T. Now for part A, we want to find out the change in internal energy. We know that change in internal energy is NCV dt. So in this case, N is 1 mole. CV, because it's a diatomic molecule, is 5 by 2 R, and R is 8.314 joule per mole Kelvin. And we know that delta T is 720 minus 420, which is 300 Kelvin, giving us 6,240 joules. Now for part B, we want to find out the work done. We know that work done is integral P dV. So we need to find volume in terms of pressure to find the work. So before we do that, we'll have to use this information. So we know that P is equal to P naught alpha T. So by substituting these two data points, we can write 1.6 atmospheres is equal to P naught plus alpha 720. And 1 atmosphere is equal to P naught plus alpha into 420. By simply subtracting these two equations, we can find the value of alpha, and it turns out to be 2 into 10 power minus 3 atmosphere per Kelvin. And then we can substitute the value of alpha back to find P naught, which turns out to be minus 0.16 atmospheres. So pressure is equal to 2 into 10 power minus 3 T minus 0.16 atmosphere, where T is in Kelvin. Now, we use PV is equal to nRT. V is equal to nRT by P, and we can write temperature in terms of pressure, nR by P. We can write temperature as P minus P naught by alpha. So we can write temperature is volume is equal to nR by alpha 1 minus P naught by P. So from this, dV is equal to nR by alpha P naught by P square dV. That is it. So work done is equal to integral P dV. So we substitute this formula for dV, and we get integral nR by alpha P times P naught by P square dP, giving us nR P naught by alpha integral dP by P, where the pressure goes from 1 atmosphere to 1.6 atmosphere. Integral dP by P is log P. So that's nR P naught by alpha log P2 by P1. Now we simply substitute our values. We have N is 1 mole, R is 8.314 joule per mole Kelvin, P naught is minus 0.16 atmosphere divided by alpha is 2 into 10 power minus 3 atmosphere per Kelvin, and we know that log P2 is 1.6 atmosphere and P1 is 1 atmosphere. This turns out to be minus 310 joules. Now that we have this, for part C, we want to find the heat. Using the first law of thermodynamics, Q is delta E plus W, and we found both the quantities, so simply substitute them. Delta E was 6240 joules, and W was minus 310 joules, giving us 5,930 joules.